3 bridges, 3 fatal mistakes. Here is how each one fell. Galloping Gertie. On July 1, 1940, the Tacoma Narrows Bridge opened across Puget Sound in Washington state. At 2,800 feet, its main span was the third longest on Earth, and it had cost $6.4 million Depression-era dollars. Drivers noticed something strange on day one. In even a light wind, the deck rolled like a ship at sea. Locals nicknamed it Galloping Gertie, and some paid the toll just for the ride. The designer, Leon Moissafe, had made the bridge slim and graceful, with solid steel plate girders down each side instead of open trusses. To the wind, those solid walls were not elegant. They were a sail. On the morning of November 7, 1940, the wind reached 40 miles per hour. The rolling stopped, and the deck began to twist. A newspaper editor, Leonard Coatsworth, abandoned his car mid-span and crawled toward the towers on his hands and knees. His dog Tubby was too terrified to leave the car and became the only casualty of the entire disaster. Just after 11, the span tore loose and fell away into the narrows far below. The wind had locked onto the bridge's own rhythm, a feedback loop engineers now call aeroelastic flutter. Ever since, no major suspension bridge gets built without a wind tunnel test. The Quebec Bridge, 1907, the plan, the longest cantilever bridge on the planet, reaching 1,800 feet across the St. Lawrence River. A cantilever bridge holds itself out from each shore like two arms, meeting in the middle. The celebrated New York engineer Theodore Cooper stretched the design longer, mid-project, without fully recalculating the weight. By August, the steel itself was warning them. Compression members in the south arm were visibly bending. Cooper wired the site a desperate order: add no more load to the bridge. The message arrived too late. On August 29th, the whole south arm, thousands of tons of steel, went down in 15 seconds. 75 workers died, many of them Mohawk ironworkers from Carnawake. 9 years later, with a new design, the rebuilt bridge was ready. As the finished center span was being hoisted into place, it dropped into the river, killing 13 more. The third attempt held. It still stands today, and it is still the longest cantilever span in the world. Canadian engineers wear an iron ring to this day in memory of the lesson. The lesson was not about steel. It was that no engineer, however celebrated, gets to skip the arithmetic. The Silver Bridge, Point Pleasant, West Virginia. December 15, 1967, rush hour 10 days before Christmas, and the bridge across the Ohio River was packed bumper to bumper. The bridge hung from chains of steel eyebars, giant links with a hole at each end, joined 2 at a time. 2 per link meant something brutal. If one broke, its partner carried everything. Inside eyebar number 330, a crack had been growing since the bridge opened in 1928. It was 1/10 of an inch deep, too thin to see, in a place no inspector could reach. At the height of the evening rush, it let go. The chain unzipped, and in under a minute the whole bridge was in the river, taking a line of loaded cars with it. 46 people died 10 days before Christmas. Within months, Congress created the National Bridge Inspection Standards. Every bridge in America now gets inspected on a schedule because of eyebar 330. 3 bridges, a sail nobody saw, a sum nobody checked, and a crack nobody could reach. Engineering learns from the failures it swears never to repeat. For the next set, subscribe.